We're on 7.3. I can perform operations with functions. So we are going to write functions right here, and we're going to perform some operations with functions. Stop and think about what operations we've learned so far in math. That might give you a hint as to what we're going to do. So here in the warm-up, we've got f of x equals 2x squared minus x minus 8, and we want to find f of negative 2. Just good practice here, making sure that we plug things in parentheses. So I'm going to put a negative 2 right here. And then always a good idea to plug in parentheses. So I'm going to go ahead and put that negative 2. Every time there was an x, I'm going to put a negative 2 in parentheses. Really good habit to be in, always putting those in parentheses. You tend to make fewer mistakes in the long run. So let's take a look and see what we get here. This would be negative 2 squared, 2 negatives. Negative times negative is positive, and 2 squared is 4. So this is 2 times 4, so we end up with 8. Then we get a plus 2, and then we get minus 8 right here. So you'll notice that those 8s will cancel each other off. So we end up with f of negative 2 is equal to 2. And remind yourself, what does that mean about the graph? What does that mean about those function values? Which one's the x? Which one's the y? All that sort of stuff. What is the domain of f of x? So this function right here. You'll notice that there are no even roots. There's no division or anything like that. So we can plug in anything that we want there. So that would be from negative infinity to infinity. Another way that you could say that is all real numbers. Either way there would be fine. And then just again, a quick reminder, we already mentioned this. There are only 2 operations we know of so far that cause domain issues. I mentioned them when I was talking about this right here. So the first one is division. So we'll write division. And here's what's not allowed. You can't divide by 0. So can't divide by 0. And then the other one are even roots. So if you've got an even root, a square root, a fourth root, and so forth, we can't take the even root of a negative number. So can't take even root of a negative number. So negative number. So for example, this would not be okay if we had the square root of negative 4. Not okay right now. And then also if we had something like this, let's just say we had 4 divided by 0. Can't divide by 0. Now, we're really familiar with functions at this point. What we're going to learn how to do now is perform operations with those, and that's going to get us ready for the next few topics that we're going to learn this year and some topics that you're going to learn in the next couple of years. So what we've got right here on example number 1 looks really weird. It says f plus g of x is the way we say that, and f minus g of x. Don't be fooled. These parentheses here, we're not saying we take f and g and add them together and then times it by x, and f minus g and then times it by x. What we're saying here is we want to take f of x and we want to add it to g of x. Now, we could have just as well written f of x plus g of x, and that would have been just fine. And over here we can write f of x minus g of x. That would have been okay too. But this is just kind of the standard notation that's been adopted for this. So if we see the name of a function and the name of another function and then an operation in between them, that operation is what we're supposed to do with those. So we're supposed to find f plus g of x and f minus g of x for both of these. So for the first one, if I want to find f plus g of x, that's how we write that, here's what we do. We're going to take f, so we're going to take 2x squared minus x plus, minus 8. And then we're going to add this stuff right here. Now I'm going to add 3x minus 2, and if we wanted to, we could put everything here in parentheses, but you'll notice because we're adding these together, we're basically just going through and collecting like terms. So this is going to be 2x squared minus x minus 8, and then plus 3x. Kind of thinking of that as distributing right there, and then minus 2. So what we're going to get here is we've got a 2x squared. Got that one taken care of. We've got negative x plus 3x, so that's plus 2x. Got those taken care of. And then if we put the 2 of those together, we end up with negative 10 right here. So f plus g of x is 2x squared plus 2x minus 10. And then if we do f minus g of x, here's what we'd end up with on that one. I'm going to go ahead and write down f, so we'll just write that down. And then we're going to subtract. Now here it is a big deal if we put this in parentheses, because what we want to do is we want to subtract each one of those. Now I'm going to save a little bit of work on this one. I'm going to distribute through here. I'm not going to rewrite that one. I'm just going to write down minus 3x, and then I'm going to write down plus 2, because a negative times a negative would be a positive. So we've basically got that expression taken care of. Now we're just going to collect like terms. We've got the 2x squared that we had to begin with, and then we're going to put together the minus x and the minus 3x. That's going to be minus 4x, done with those. And then we have a negative 8 plus 2, that's going to be negative 6. All right, so this is f plus g of x, and this is f minus g of x. And then we'll take a look at this one. The only difference here is that we've got, instead of these polynomials right here with squared terms and regular linear terms and so forth, we've got some exponential expressions right here. So let's go ahead and write down f plus g of x. And we're going to write down 4, 3 to the x, minus 6, and then plus 2, 3 to the x, plus 7. And again, we could put everything in parentheses here, but you'll notice that because we're adding, it's not going to change the sign of anything. So we're just going to have 4 to the 3x, or 4 times 3 to the x, 2, 3 to the x. So if I have 4 of these plus 2 of these, I have 6 of those altogether. So that's going to be 6, 3 to the x's. And then we have minus 6 plus 7, so that's going to be plus 1. So there's f plus g of x. And then f minus g of x. And again, I'll write this down, 4 and then 3 to the x, minus 6. And I am going to go ahead and write this down in parentheses. Just a quick reminder there that we need to make sure we distribute that through here. So we have minus 2 times 3 to the x, and then minus 7. So let's combine these guys together. That's going to give us a 2, 3 to the x, because if I have 4 of these and I take away 2 of these, that gives me 2, 3 to the x's. And then negative 6 minus 7, so that's going to be negative 13. I'll go ahead and circle that. Okay, so really what we're doing here is we're doing a lot of just simplifying, collecting like terms, making things look as nice as we possibly can. If we take a look at example 2, though, on example 2, the operation that we're doing is different. So this is multiplication and division. So that's going to introduce something new here. And remember, when you're dividing, you can't cancel terms, you can only cancel factors. And I'm going to show you a common mistake that a lot of people make here. So if I do f times g of x, here's what we get. We get 8x, and then we're going to multiply it with 4x minus 1. We just do some simple distributing. So this is going to be, let's see, 8 times 4, that's 32. 32x squared, and then minus 8x. So there would be the answer there. And now we're going to do the division problem. So we do f divided by g of x. G of x. And we're going to have an 8x on the top, and we have a 4x minus 1 here. Now, this is why I put a little reminder over here. This is what a lot of people will look to do. They'll say, oh, I can cancel off the 8x with the 4x. I can cancel off the x with the x and the 4 with the 8. This would be a 2 here and a 1 here. And then they do all sorts of crazy things after that. You can only cancel factors. You can't cancel terms. So I can't cancel this 4x here with the 8x up there because this 4x is attached to the minus 1. It's a term that's part of this binomial right here. There is nothing we can do to simplify this. So the cool part about this is we just get to circle that answer right there and we're done. Okay, so let's take a look at the next one. We're going to multiply the two of these together. So we're going to do f times g of x. So we're going to write down 6x squared minus 3x plus 12. We're going to put that in parentheses because we're doing multiplication first here, remember? So this is going to be 4x squared, and then I'm going to take this one and I'm going to multiply it through by every single one of these. I'm taking this monomial here and I'm multiplying it with that trinomial. So I am going to get 3 terms by the time I'm done. So this is 4x squared times 6x squared. That's 24x to the 4th, remember? Multiplying these together, we add the exponents. Then we have 4x squared times negative 3x. That's going to be negative 12x to the 3rd. And then I've got 4x squared times 12. That's going to be 48x to the 2nd. You'll notice that there really aren't any like terms here, so we're done with that one right there. And we can move on to doing the division one. So this is going to be f on the top and g on the bottom because they told us that was the order that we needed to. So let's see here. F on the top is going to be 6x squared minus 3x plus 12. And then the only thing on the bottom is the 4 and the x squared. Now, again, you might be tempted to look at this and say, hey, I can cancel the x squareds. You can't. That x squared is part of that 6x squared term that's part of this whole trinomial. We can only cancel factors, and I'll show you a little bit later on how we deal with that. So this is it right here. That's all we can do. We can go ahead and circle that. And just a little note here, when we're dividing polynomials, there's really not much that can be done to simplify them right now. You are going to learn some skills later on that will make it so that you can do some simplifying. I'm going to show you a very, very simple type of simplification that we can do on this that'll bring back some stuff that you learned in 7th grade. So let's slide down here and take a look at example number 3. So here's what it wants on example number 3. It wants us to do all of these. It wants us to add them, subtract them, multiply them, and divide them. And here we've got some exponential expressions. Notice that there's only one term in each one of them. There's no adding or subtracting. So this might be kind of interesting. So we're going to do f plus g of x, and we get, here's f, 4, 5 to the x, plus 8, 5 to the x. So altogether we would have 12, 5 to the x. Go ahead and circle that. If we do the subtraction one, f minus g of x, this is going to be the first one, f, 4, 5 to the x, minus 8, 5 to the x. Lo and behold, it ends up being a negative 4, 5 to the x. Okay, and then we're going to do the multiplication problem. So let's see what we get here. Let me put a dot right there. F times g, of x. Get ahead of myself there. So we're going to do 4, 5 to the x times 8, 5 to the x. And you might recognize this type of problem from the last section that we did. We're going to multiply the coefficients together, so that's going to give us 32. So I probably ought to circle that one. And then when we multiply these together, they have the same exponent, so we can actually multiply the bases here. So this is going to be 5 times 5, that's going to be 25 to the x. And if you need a reminder as to why that works the way it does, just look up that last set of notes because we did talk about that. And then here's the last one. We're going to do f divided by g of x. So we're going to do f on the top, so that's going to be 4, 5 to the x, and 8, 5 to the x. And notice what we have here. We can cancel the 5 to the x over 5 to the x, same thing over same thing. And then we have a 4 on the top and an 8 on the bottom. 4 goes in here once, 4 goes in here twice, so we end up with a 1/2. So when we divide these, we always end up with 1/2. Now, a little thought experiment here. All of the original functions that we've been working with up here, they all have a domain that includes all real numbers. So that would be that negative infinity to infinity. Now, the results of these operations, when we add them, subtract them, multiply them, or divide them, that may change a little bit. So did any of the operations affect the domain? Well, adding isn't going to introduce any domain problems. Neither is subtracting, and neither does multiplication, but division does. So we might have to be a little bit careful when we're finding division. Now, we didn't ask you to do any of this. You don't have to find the domain or state the domain for any of these. But when we've got a division problem, what we'd want to do is we'd want to make sure that the denominator can't be 0. So I'm going to slide up to this one right here on example number 2. And let's take a look at these two division problems right here. So on this one, we would not want that denominator to be 0. Well, stop and think for just a second. What could I plug in that would make that equal to 0? In other words, when would 4x squared be equal to 0? Well, if you remember your solving techniques for solving quadratics, we can solve this. Let's isolate the variable terms. So let's divide both sides by 4. That would be x squared equals 0. And then to find the x value here, to get rid of the squaring, say it the right way, we take the square root of both sides, so we get a 0 right here. So the domain would have to be restricted in this case. We couldn't go from negative infinity to infinity anymore. We'd have to say, you know what, you can do that, you just can't have it equal to 0. So again, you're not going to be asked to do anything like that. You're not going to be asked to find out what the domain is, but it's a good thing to keep in mind. And I'll leave this one right here for you to think about. We can plug in anything we want into these original ones, but once we start dividing, we've got to make sure that we're not dividing by 0. So stop and think how you do that for just a second. Just like we did over here, we want to know when that denominator is equal to 0. So if you set that equal to 0, that will tell you where the problem is in the domain. So go ahead and do the self-assessment right here, and then let's take a look at number 16 from the assignment, and I'll show you a little bit of simplification that can be done with polynomials when we're dividing. All right, this is assignment 7.3a, operations with functions. Let's slide down here and let's take a look at problem number 16. On number 16, it asks us to do multiply and divide here. So f times g and f divided by g. So let's go ahead and take a look at the f times g. We've done one like this. We did one like this just a second ago. So this would be f times g of x. You'll notice that the only difference here is this number has changed. So let me show you what happens with that. We're going to have 2x squared minus 4x plus 8. Nothing crazy happens when we do this. We're just going to go ahead and distribute through, and I'll let you do that because we've done that before. The only difference, again, is that number right there. But watch what happens when I do f divided by g of x. This is going to be 2x squared minus 4x plus 8. And then on the bottom, we're going to have 4x squared. And a lot of people will look at this and think, my gosh, there's got to be something that we can do with this. Well, it turns out there actually is, because all of these numbers happen to be even. We still can't cancel the x's, and we still can't cancel a 4 with any one of these, but what we can do is this. We can take out the GCF. That's the first rule in factoring, so take out the GCF. Take out GCF. So watch what happens if I take out the GCF. So what number or what variable can I take out of here? What's the biggest number that I can take out? Biggest number is 2. And can we take out any variables? We can't take out any variables because that one doesn't have an x on it. So if I take out a 2, I'm left with x squared. I'm left with minus 2x and then plus 4. And then the denominator is still this 4x squared. Now notice that this is 2 times this stuff right here, and it's 4 times the x squared right there. I can go ahead and I can cancel those coefficients here. So 2 goes in here once, 2 goes in here twice. So this would be the simplified answer for this particular one. We're going to have the x squared minus 2x plus 4 on the top, and then we're just going to have a 2x squared on the bottom. Now, again, you'll still look at that sometimes and say, my gosh, we've got a 2 and we've got an x squared. Why can't we cancel those? Again, we can only cancel factors. We can't cancel terms. That x squared is a term. The x squared down here is a factor. This 2 is part of a term. This 2 down here is a factor. They've both got to be factors in order to be able to cancel them. Okay, good luck on the assignment.